write it in the remainder theorem format. X plus 1
to x plus 1 whole multiplied by x square plus x plus 1 plus 0 equals x cube plus 1.
Super, brilliant. Okay, so this is how, because the remainder is 0, so we will add 0. Brilliant. Okay. Next is, again, I guess we have an example. It's saying let px be any polynomial of degree greater than or equal to 1, and let a be any real number, and px is divided by the linear polynomial x minus a, then the remainder is pa. So this is the polynomials remainder theorem which you need to understand. It's saying, for example, px is any polynomial, okay, and the degree of this polynomial is either 1 or greater than 1, and a be any real number. If px is divided by a polynomial x minus a, then the remainder will be pa. Now, for example, let's say there is a polynomial x5 plus 1. Okay. Then, if you choose x minus 1, right? This is what saying degree. Let px be a polynomial. Okay, they are not doing it example. They are doing in journal. So they have taken a polynomial here, which is equal to px is equal to x minus a. Why? Because x minus a is, we need to divide. Right? If px is divided by a linear polynomial, so we can write our polynomial in remainder theorem.
Yes,
X is equal to x minus a qx, which is quotient plus remainder. Right? Now, what is the degree of x minus a?
1.
Okay. And when I say any number, if I say 15 is equal to 3 multiplied by 5 plus 0, right?
Yes, ma'am.
So in this case, our remainder is always less than my quotient and divisor.
Yes, ma'am. Yes, ma'am.
Yes, because if it is greater or equal, we keep on dividing. Until it's less, we stop dividing. So that's why it's saying the degree of Rx is less than the degree of x minus a. In any case, reminder's degree will be less than that of the divisor x minus a, with which we are dividing the number.
Okay, ma'am.
Okay, the degree of Rx is equal to less than the degree of. Now, what is the degree of x minus a?
1.
And if 1 is the degree, then it is less the degree of. Excuse me, what? I need some water. I'm just give it to me. Sorry, I just needed some water. Yeah. Okay. So now the degree of, we said remainder is less than the degree of the divisor. Divisor is x minus a, right? And you said that the degree of x minus a is 1. So what would be the degree of remainder?
0.
It should be 0, because it should be less than 1, and less than 1 is 0. Degree cannot be negative.
Yes,
right? So that means Rx, if the degree of any polynomial is 0, what does it mean?
It becomes 1.
It becomes 1. It's a constant, right?
Yes, ma'am.
So we write it px is equal to x minus a plus r. R is my constant. Okay. So here we rewrite this equation, the normal equation, by justifying. So instead of Rx, we write it as R. Now here you said, no, ma'am, degree of anything 0. any number, if it's 0, we get 1. Here Rx is a polynomial. It can be a polynomial as well.
Okay, ma'am.
Right? So if polynomial's degree is 0 means it's a constant polynomial. It can be any constant number.
Yes, ma'am.
Right? Now they are saying, now they got this polynomial is equal to this x minus a qx plus r. Right? And in the last line of the theorem, what they said, if px is divided by the linear polynomial x minus a, then the remainder is pa.
Yes.
So put x is equal to a in this situation, in equation 1. What you'll get?
R.
R is a constant, right? R is
Yes.
a remainder. So it is saying if x is divided by a linear, means a degree, a polynomial of degree 1, a linear polynomial x minus a, then the remainder is pa.
Okay, ma'am.
Right? That is the thing. And they use this. So first they put the remainder theorem, px is equal to x minus a, qx plus rx. Since q minus rx is a remainder polynomial, its degree should be less than the divisor polynomial, which is x minus a. Right? Degree, since x minus a is a linear polynomial, its degree is 1. That's why rx degree is 0. If the polynomial degree is 0, means it's a constant polynomial. Right? So we rewrite the equation as px is equal to x minus a qx plus r. Right? And when we put pa in place of x, if we replace x by a, we get the remainder r. So this is basically the polynomial theorem. Okay. Example number 9. Okay. Now look at the example number 9. Now use the theorem that we just did. What will be the remainder of this polynomial? We have a linear polynomial here, x minus 1. Because it's asking to find the remainder only.
Okay.
Right? So what will be the a in this question?
1.
1. So what you need to find? This is px, right?
Yes, ma'am.
Find p1. You will get the remainder. Put x as 1 in this polynomial and you will find the remainder.
My answer is 2.
Huh? 2, right?
2.
Yes, that's the correct answer. So whenever in any question they just ask you to find the remainder of a polynomial and the divisor is a linear polynomial, what do you need to do? Directly put the value of a in that polynomial
Okay.
and you'll get the remainder.
Okay.
Okay. Next is example number 10 is saying check whether the polynomial qt is a multiple of 2t plus 1. Okay, so in this case, we need to find if this is a multiple of
2t plus 1.
right? So equate 2t plus 1 by 0 and find the value of
T.
t. And put that
1.
value in the if it satisfies the value, then it is a multiple. So t will be minus negative 1 by 2. Right? And they will put this negative t value in. Is it coming 0? The value will
Yes,
be great. Then it is a multiple. Okay. Now we will do exercise 2.3. In 2.3, now read the first question. Find the remainder when The given polynomial is divided by the polynomial given. Right. Okay, Vivang. Just now we did remainder theorem. So what we will do here?
Ma'am, for example, I take
শীতের সকাল যা আগে দেখবি তো ছবি দেখে বুঝতে পারবি না শীতের সকাল কোনটা
I'll find
শীতের সকাল মনে হচ্ছে
I'll equate it to 0.
Okay.
And then I'll find out what x is.
শীতের সকাল
Once I do
এবারে
that,
হাওয়া তো হাওয়া
I'll see
একেবারে
if I'll see the remainder. Then I do remainder.
All right. The divisor is a linear polynomial.
Yes,
Then
ma'am, that's the name.
Yeah. So in the first part, what is the a in x plus 1?
হবে তো এটা
1.
ভাগ লাগবে
One.
সকালে
Put the value
হবে তো
1
এটা
in the given field. Find p1. Tell me what is the remainder.
হ্যাঁ
সেটা করো কে
বাবা ডাকছে ও স্যার করে দিচ্ছে বাবা ডাকছে এটা বলতে হবে
আরে আগে তুমি তো শেয়ারটা করো মৌলিকে পাঠাও না তাহলে আমি দেখছি
তুই জানা তাড়াতাড়ি তোর বাবা জিও না আমি পাঠিয়ে দিচ্ছি বললাম তো পাঠিয়ে দিচ্ছে
1 second.
Yeah.
হবে আজকে দেখ না আওয়াজ হয়েছে
হিন্দি বলে
আওয়াজ হয়েছে
Okay. Just a question. Your a. What is a?
1, ma'am.
1 or minus 1?
1.
1. A.
1, ma'am.
According to this remainder theorem, if my polynomial is linear, which is x minus a.
Oh,
Right?
yes, ma'am.
It should be linear and a should be with a negative.
YOLO.
See? It's by the linear polynomial x minus a. So put p minus 1 that we need to find.
Is it 8?
Let me check. Minus q will be minus 1, then plus 3, then minus p plus 1. It's coming out 0 for me. If a is minus 1.
Oh, yes, ma'am. To cancel it.
Yes. Negative sign, keep in mind. Okay.
Oh my god. 19 by 8 plus 1.
19
19
by 8. So now take LCM. 19 plus 8 by 8. It would be 27 by 8, right?
I want to. Yes, ma'am. 27 by 8.
Right? Great. Okay. Third part, what is A in it?
1 minus
How
1.
can I write it? It's x. So can I write x is equal to x minus 0?
Yes, ma'am.
right? So what is A here?
0.
0. So find P0. Don't solve. Look at it and tell me you can do it. What will be the P0?
1 plus.
Everywhere X, you will put the 0.
Yes, ma'am.
Huh?
8.
X is 0. You will find.
Oh, sir. Okay. 1.
So x cube will be 0 cube plus 3x square will be 30 square plus 3x will be 30 plus 1. So all the first three terms will become 0. Remainder will be 1.
Okay. Ma'am, but
Ah,
isn't the square only for, isn't the exponent only for x?
okay, just one. Now see. Let me just erase it. Ah, okay. Okay. So I will write this x as x minus 0. Right? So here my a is 0. Correct?
Yes.
So my A is 0, so I need to find PA. And my A is 0, so I'll put P0 in this. So don't you think I will write 0 to the power P plus 3 to the power 3 into 0 to the power 2 plus 3 into 0 plus 1. So all the three terms will become 0. This will become 0. This will become 0. This will become 0. What will be the P0?
Oh, okay, ma'am. Okay, ma'am. 1, ma'am.
1. You were thinking the power will be the 0, right?
Yes,
And
ma'am.
making
Yes,
it 1, 1, 1.
yes.
Yes. Divine. Okay. Okay, next one. So next one is x plus pi. What is a in this?
Pi. No, minus pi. Minus pi.
Minus pi. So find p minus pi.
Oh, I can write pi is minus 22 by 7 on this. Right?
No, no, use the same pi. Don't change it then. If in exam they give you pi, you will have to respond in pi only. The remainder will be pi cube plus 3 pi square. No, minus pi cube plus 3 pi square minus 3 pi plus 2. Yes? Last fifth one. How will you do? Equate it to 0, put the value of x in it and check if 0 is coming, what value you are getting. That is your remainder.
Okay.
Yeah.
Ma'am, is it minus 43 with 100, ma'am? Ma'am, 43 by 8. Minus 43 by 8.
Minus 43 by 8. Mine is coming really different. But I might be wrong. I think, yeah, yours is correct. Right. I did a little negative mistake. Okay. So, we are going to the next one. They have given you one polynomial, x cubed minus ax squared minus 6x minus 8. Right? And they have given you the divisor x minus 8. So, what is a?
A.
A is a, right? So, find PA directly. Put the value of x as a. find that what remainder do you get?
Then is it 4a?
What if I say it's 5a? Because a cube minus a into a square. So the first two term will get cancelled out and 6a minus a will left, which will be 5a. I'll put the value. This, if I find pk, first it will be a cube, right?
Oh, okay.
Minus a square minus plus 6a minus a. Right? So this is a cube minus a cube. They'll get cancelled out and we will left with 5.
Okay.
Yeah? Done? Okay. Now the last one of this exercise 2.3. Check whether 7 plus 3x is a factor of 3x cubed plus 7x. So again, here equate this. For the factor, equate the divisor with 0. Find the value of x and put that value of x in this. If you get 0, it is a factor. If you does not get 0, it is not a factor.
Ma'am, it is
Not a factor, right?
not a factor.
Because we are getting like minus 490 by 3 some kind of remainder. Okay. Now this was we talked about remainder theorem. Now next term is a factor theorem. So factor theorem is in this the sums are like this only, right? So let's begin with the example itself. So I'll take you to the first example. Okay. So example says x plus 2 is a factor of examine of this polynomial and this polynomial. Now, you know that how to do, right? X plus y plus 2 equated to 0, find the value of x and put that a value in the polynomial. If it is 0, it's a factor, right?
Yes, ma'am.
That's only factor theorem. Now, if you look at this polynomial, there's an easy way out to find out whether it's a factor of the given polynomial. We want to take 2 common. If I take 2 common in this polynomial, can I write this as 2 into x plus 2?
Yes, ma'am.
Right? So, clearly, if I rewrite this polynomial as this, clearly it's a factor. X plus 2 is a factor of this polynomial.
Yes, ma'am.
Right? So, in this exercise or examples, you have to apply such tricks to check whether they are factor or not. Otherwise, you have this big trick with you that equate x plus 2 is equal to 0. Here x will be minus 2 and put the value of x here minus 2 and check if 0 is coming. Check here. Find 3 minus 2 and tell me if it's coming 0 or example. Okay. Now this is interesting. Okay, so now if you read the example number 12, it says, just one second now, plain is good. They have tell you that this x minus a is a factor of this polynomial. Okay, they have told you, they're not asking you to find whether it is a factor or not. Which means if I put x is equal to 1, right? This polynomial should be satisfied, right? It should be 0.
Yes, ma'am.
D1 should be 0. Correct?
Yes,
and
ma'am.
they have asked you to find the value of k. So now put the p1, equate the p1 is equal to 0 and find, tell me what is the value of k in this question. What is p1? Just p1. Tell me p1.
4 plus 3 minus 4.
So if you solve it, we will get 3 plus k is k, right? P1 is equal to 3 plus k.
Yes, ma'am.
Equate it to 0 because
Minus 3.
So the k value is minus 3 because P1 is 0 as they have already given us x minus 1 is a factor. Right? So that's why P1 should satisfy the polynomial. Right? So this is it for today. Next time we will learn this splitting the middle term. It's very, very interesting, right? In a given polynomial of 3 terms, we break the middle one and then find the factor of that polynomial.
Okay.
Okay?
Okay.
Alright, darling. Thank you. I enjoyed teaching you just like always. We will see you.